what is a systematic error? Systematic error is an error which is fixed in number, and either it is on the higher side or on the lower side. This error is constant in magnitude and direction, and graphically it appears as an intercept. So when there is a systematic error, the graph will show an intercept. There's some observational issues, imperfect instrumental calibration, temperature, pressure, theory, etc. Acha, the simple example of a systematic error is a zero error. You have to copy this example. Yeah. Now, this can happen when measuring the height from a desk with a 30-centimeter ruler, and the measurer forgets that the ruler does not start at zero. Normally, when you look at a ruler, especially the wooden big ruler and the plastic rulers, they do not start from zero at their edge. So these rulers are always having a zero mark. These rulers have a zero mark, but when you touch them, like this is a ruler and it starts from here, but you will notice that the zero mark is slightly above. So this is the zero mark. There is some gap. There is some gap between the zero line and the edge. This gap in our language, this gap is called dead distance. Due to this gap, when you put it on a desk, what happens? When you put it on a desk, it won't read the exact position because some reading is already there. So it's not touching zero when it is touching the desk. This is called zero error. There are also other reasons like zero error is forgetting to set a top end balance. You forgot to put zero error there. Systematic parallax error also exists. As I mentioned earlier, the point is not parallax error. The point is not zero error. The point is there if error is the same. How many times you repeat doesn't matter. And then it is systematic. If error fluctuates, it is a random error. A systematic error cannot be eliminated by averaging. You have to copy this. Now, there are two types of error. One is called systematic error and one is called random error. This is a way to remember it. And I will, inshallah, share this chart with you so you remember it. Errors are an important topic. The same concept is in detail here. The idea is there. The idea is there that error can be classified either in fluctuating way, then it is random error. And if the error is fixed, then it is systematic error. Now you have to give a heading, accuracy and precision. Give a new heading. Now the concept comes here. The concept comes here with the title of first accuracy. Accuracy is compared with the true value. Normally, we take an example. Let's suppose we know that the value of G is 9.81. Let's say we take it 10. The value of G, the true value of G, let's suppose it is 10. So when you talk about accuracy, so suppose you take one trial, you got 11. The second trial, you got 10. And the third trial, you got 12. You got 3 readings. It is visible, the readings are quite fluctuating. But if you find out the average, the average will go and become 10. Now, as the average value, as the average value is close or equal to the true value, we will say that it is accurate. So what is accuracy? Accuracy is a measure of the extent to which you are close to the true value, but you have to consider the average value. Then what is precision? Precision means how much the values are close to each other. For example, G is equal to 7.9, G is equal to 7.8, and G is equal to 7.7. These values are never accurate. If you even take out the average, average is not going to be 10. So it is not accurate, but the values are very close to each other. So this is called precision. Precision means, for example, your stop clock is having an error of 5 minutes. So whenever you take the reading, it will be 5 minutes wrong. Accuracy is not there. But you know how to use the stopwatch and you give the readings every time in the same range, then it is precision. So what is precision? How much your values are close to each other. And what is accuracy? How much your average value is close to the true value. This is the background, and after giving the heading, first copy the definition of accuracy.
Yeah.
Accuracy is the extent to which measurement is close to the true value. I have shared with you the important charts, and as usual, these are our the picture notes, and you can make a separate folder or you can shift to them so that you have because the time is very limited. So these 2 chapters you can improve quickly. Average value versus actual value. This is a game of accuracy. So for example, G is equal to 10. The values are visible that they are never precise. They are too much far away. But if you take out the average is coming 10. It means it is accurate. So look at this point. Average value is always compared with the actual value. So if you copy this,
Done.
then copy this example.
Done.
Now, we talk about percentage error because accuracy is actually a measurement of error. When you want to measure error, you have to use the formula error upon true value into 100. And this will be a reverse rule that if error is suppose 20%, then accuracy will be 80%. If error is 30%, then accuracy will be 70%. You have to copy this.
Done.
Now, here we introduce another concept, which is mainly the concept of paper 3, and it is called tolerance level. What is tolerance level? It is a concept of error sustainability. How much error you will allow. So, for example, someone tells you that I will come to you, but I may be 10 minutes late. You will say, okay, fine. But if the person says, no, I will be 2 hours late, then you say, no, this is beyond my time space and I cannot wait that much. This is in physics called as tolerance level. In our course, the tolerance level is 10 to 20%. If error exceeds 20%, then error means that error is not removable and the answer is wrong. This is the same tolerance level which you find in the marking scheme. Examiner says this much error is allowed. So copy the tolerance level also.
Done.
Precision is the extent to which readings are close to each other. You have to copy this.
Done.
So precision means how much your values are close to each other. It depends upon the idea that your method of reading the data is accurate or not. As mentioned that this is again a topic which is not coming every year. Precision and accuracy is a rare topic that it comes not commonly. It is not a common topic. Now look at these values. All of them are far away from the true value, but they are very close to each other. So this is called precise but not accurate. You have to copy this screen.
Done.
Now, we normally talk about these sketches in a verbal sense. Sketches is something which is always there in our paper 1. And this is the left side sketch means the spread is high. The graph has a bigger base. So it means more spread, less precise. And if you look at this sketch, it has less spread, more precise. Look at these values. This sketch means this is the true value. This is the accuracy. This is shows accuracy because the average is close to the true value, but it is not precise because it's a slim graph. When you see this graph, it has a wider base. It has a wider base, but it is away from the true value. So it is neither precise nor accurate. Look at this sketch. The values are close to, the values are not close to each other, but their average is on the true value. It is accurate, but not precise. So a result may be accurate, not precise, if the measured value is close to the accepted value. Now, case number 4, the graph is slim. It's a slim graph, which means it is precise, but it is far away from the true value, so it is not accurate. So a precise but inaccurate result may be due to systematic error. If the precision is there, but you're getting a permanent wrong answer, it means there is some fixed error. Fixed error means system. Fixed error means that the error is systematic. You have to copy this screen.
Done.
Now, give the heading uncertainty. This is the main topic of this chapter, and this topic is considered to be the most important in this chapter.
Done.
Now, what is uncertainty? Uncertainty is simply translated as a known error, but it is like a provision. It is like a provision rather than a mistake. For example, when we look at the marking schemes, we normally answers are written like this, plus minus 0.5. So it means 2.5 is possible. It means 1.5 is also possible. This is called uncertainty. So uncertainty is a measure of range of error. So this is called uncertainty, and uncertainty is a known error which can be in any direction. The symbol is this, which we read as DEBA. So you have to copy first the symbol.
Done.
Uncertainty is the range of values on either side of a measurement within which the true value is expected to be located. So you have to copy this.
Done.
This is the definition of uncertainty. Look at this famous type of example. These are called marking scheme patterns. Length of a rod is 20 plus minus 2. So it's a provision of 2 plus and provision of 2 minus. Mass of a block 2 plus 2 minus. You have to copy these examples.
Done.
Uncertainty is the known or expected error in a medium. This is an error which we already know from the system, from the working, or from the device. So we already know that this much fluctuation is there. For example, you are going somewhere regularly and you have a pattern, you have understanding of traffic there. So you can guess that maybe you are 10 minutes late or maybe you're 10 minutes early. The 10 minute is there, up and down, both number is the same. Then it is uncertainty. You have to copy this concept also.
Done. Done.
Uncertainty is the range of error in a measurement. Then a very important concept comes. Uncertainty is always correct to one significant figure. You have to copy this.
Done.
Now look at this. For example, 52 plus minus 17. So you will write 52 plus minus 20 because 20 has one significant figure. You have to copy this.
Done.
Concept of uncertainty is very close to systematic error, yet they are two different things. Actually, it should be noted that an error cannot be on both sides. You cannot say that I got an answer which can be 2 unit up or 2 unit down. This is the difference. Error is either less than the true value or greater than the true value. Either it is an underestimation or overestimation. But uncertainty is a special type of error which is on both sides. What are the common sources of uncertainty? Pre-allocated, you know in advance that this much error will come due to the least count. Least count is the smallest division which an instrument can take. It is a source of zero error. Uncertainty due to limitation of experimental procedure. You cannot measure everything with maximum accuracy. So there is always some known limitation due to rounding error. When you note down the values, you keep them round, you have to round them. This introduces an error which was in our O-level maths also. So say 20.1, it can be 20.05 and 20.15. This is called rounding error. Now you have to give a new heading, types of uncertainty. There are three types of uncertainties.
Done.
Now, look at the example. Number one, absolute uncertainty. Number two, fractional uncertainty. Fractional uncertainty means you divide it by the true value. Percentage uncertainty is actually a type of ratio with a percentage multiplied by 100. You have to copy this.
Done.
For example, mass is 30 plus minus 1. Then absolute uncertainty is 1. Fractional uncertainty is 1 upon 30. And percentage uncertainty is 1 upon 30 into 100. You have to copy this.
Done.
If uncertainty is given in percentage, for example, mass is having an uncertainty of 3 upon 3%, then actually percentage means that you remove the percentage sign and divide it by 100. So you have to copy this.
Done.
Uncertainty is calculated to check the level of accuracy of a measurement. Uncertainty is an aggregating factor. So what it means that whenever you are calculating, you always go for a number of steps, step 1, step 2, step 3. So physics says that uncertainty always increases. It never decreases. Uncertainty should not be subtracted, should not be raised to a power, and normally should not be subjected to a unit conversion. You have to copy this.
Done.
Again, uncertainty should be given correct to one significant figure. Now we put our next concept. Uncertainty is mainly a calculation topic. So there are so many small things. It is better to modify a formula rather than a given value. Now, given value means given numerical value. So when you are dealing with uncertainty, you should always try to avoid altering or modifying a value, uh, means numerical value. For example, area is a question mark. Diameter is given. So I have two options. First, I can convert diameter into radius, or I convert the formula. It is better to alter the formula, because if you divide 20 by 2, that's no problem. But you cannot divide 1 by 2, because you can't change uncertainty numerically. You can't change uncertainty numerically. You have to copy this screen.
Done.
Then copy this screen.
Done.
Constants are ignored in uncertainty calculation. This is a very simple, but normally people take time to understand that uncertainty is a feature of a variable. When you say x is equal to 2, actually, when it is a constant, it cannot have any uncertainty. Until you get it in a number, uncertainty it can be found, but once it is in a number form, uncertainty goes out. So when you are calculating pi d square upon 4, 4 and pi are constant, they should be ignored. So you have to copy this screen.
Done.
So you have to copy this screen.
Done.
uncertainty calculations. Now you have to copy this screen.
Done.
I'm putting the first calculation feature, sum and difference, the formulas which involve sum or the formula which involve difference. You have to copy this heading, side heading.
Done.
Look at this case, u is equal to x plus y deba u if the formula is in plus. If the formula says two quantities are being added, so the uncertainties will also be added. When the two quantities in the formula are added, the uncertainties are also added. You have to copy this.
Done.
Now look at this example. M1 and M2 is there with uncertainty, and we need to find the total mass. Logically, total mass would be the sum of the two masses. So it falls under the title of U is equal to X plus Y. You have to now copy this.
Done.
Look at the working. The total mass is the sum of the two masses, and the total uncertainty is the sum of the two uncertainties. So you have to copy this solution.
Done.
So the uncertainty, theoretically, the uncertainty will be 53, but when you write the, sorry, uncertainty is 3, which is correct to one significant figure. This is the case of sum. This is the case of summation when you are calculating the uncertainty and you want to find the final answer. And whenever you write the final answer, you have to write it with absolute uncertainty. Now, see the formula. U is equal to X minus Y. If two variables are subtracted, their uncertainties are still added. You have to copy this.
Done.
So think about an example. R capital 1 is the external radius, small r is the internal radius, and t is the thickness. So t is equal to r minus x. So you are going to find the thickness. So when you find the thickness, you have to subtract it and you have to find the thickness. You have to copy this screen, this example.
Done.
Now look at the formula, the thickness. Thickness is equal to 20 minus 11. 20 minus 11, the thickness is 9. You have subtracted the two variables, but when you talk about uncertainty, you will add them. So even the quantities are being subtracted, uncertainties will be added. You have to copy this.
Done.
This chapter is actually a combination of two chapters in our last year books which we were using. It might be in two chapters, the physical quantities and measurement. This big chapter is now finishing. So when you start the past paper, you might get this topic in two headings, maybe. Now, the title is product. When two quantities are in multiplication, you have to give this heading product.
Done.
Now, this is the formula for the product. When two quantities are in multiplication, we add up their fractions. You have to copy this. I'm just coming and you have to copy this. Have you copied it? Have you copied it?
Yes, yes, done.
So we keep it up to here and we will inshallah continue in our next class. Allah Hafiz.